In this video, we're going to talk a little bit about catalysts. So let's first imagine that we have two reactants. And I'm going to simplify things with these overly simplified drawings. So let's say you have this reactant right over here, and I'm drawing it that way for a reason. And then let's say I have this reactant that looks something like this. And obviously, if we're talking about a chemical reaction, we're not usually talking about just two different molecules. We're talking about many trillions of molecules that are oftentimes in some form of a solution. But here we're just giving an example of one of each types of the reactant molecules. So let's imagine that if they are able to run into each other with sufficient energy and with the right orientation, they're going to bond with each other. So these two reactants would react to form this product that looks like this. And obviously, as I mentioned, this is a oversimplification, but it gives you the general idea. So it might form a molecule that looks like that. Now, as we mentioned, it has to have the right energy and the right orientation. So we can think about this in terms of an energy diagram right over here, where in this axis, let's call this the progress of reaction. And in this axis, let's just say energy. Now, we have our reactants that are at a certain energy level when they are left to their own devices. But if they have enough energy added to the system, they are able to react. And then after they react, the product will have a certain energy. So this is a reaction where we've had to put energy into the reaction because the products have a higher energy than the reactants. So this is the in this case, there's just one product. Let's call it products, and let's call this reactants. Now this hump over here, where we have to put even more energy than we end up with our products at the end, we call that the activation energy. The energy that you need in order to make this reaction happen from left to right. So this right over here is the activation energy. Activation energy. Now, I said that this video was going to be about catalysts. What does a catalyst do? Well, a catalyst can lower the activation energy for a reaction. It's not a part of the reaction. You could view it as a bystander. It's something that's helping the reaction happen. It's not getting used up in the reaction. It's not getting produced in the reaction. It's just helping the reaction happen. And it would help it by lowering that activation energy. So if you have the presence of a catalyst, it might look something like this. So all of a sudden you need less energy to get over this hump and to form the products. Now, what could a catalyst actually be that does that? Well, we could think about biological systems where a common catalyst is an enzyme or enzymes. And one way that they lower the activation energy, it could be providing a surface where the reactants can react. It could be to make it a little bit easier for them to get in the right orientation. So, for example, imagine if you had a huge enzyme that looked something like this. And this, once again, is an oversimplification. And it just happened to be that this part of the enzyme, it's able to bond to that first reactant. Let me do that same color. To that first reactant, and puts it into the right orientation where this other part of the enzyme can bond with that second reactant and puts it in the right orientation so that you don't need quite as much energy for them to be able to react with each other. And you might say, well, why do we even need these? Or why are enzymes even important? Remember, enzymes are a type of catalyst. Well, it turns out that your body or many biological systems need a lot of reactions to occur, but without a catalyst, and in this case in a biological system, without an enzyme, the temperature would have to be too high where all sorts of other bad things will happen. But by having catalysts, in this case an enzyme, it allows the reaction to proceed, in this case from left to right, without having the energy be so high that it's damaging to the system as a whole. So it's able to have this reaction happen at a lower energy, or in this biological system, at a lower temperature.